So in this video, we're going to look at three different conics, a parabola, an ellipse, and a hyperbola. We're going to sketch a graph and write the equation based on the information that we're given. In this first example, we're looking at a parabola. It has a vertex -7,3, a focus of -5,3, and a directrix that's x equals -9. So I'm going to start out by sketching this graph. And I'm going to say this right here, -7, 3. Our focus is at -5,3. So the focus would be right here, and the directrix is over here at x equals -9. So based on the positions of these points in this line, I can see that my parabola is going to be a horizontal parabola, and it's going to open to the right, like so. Now to write the equation for this parabola, since we are opening to the right, that means that my y term is going to be squared, and so we're going to use the form of the equation, x minus h is equal to 1 over 4d times y minus k squared. My h and k are the vertex, and so my h is -7, so this is going to be x plus 7 equal to y, and my k is 3, so y minus 3 squared. So all I need now to complete this equation is to find that d value. Now the d value is the distance from the vertex to the focus. This distance is d, and it's also the same as the distance from the vertex to the directrix. And both of these distances here are 2. So our d value is 2, which means 1 over 4d would be 1 over 8. And last thing I want to think about is the sign here, if it should be positive or negative. Since my parabola is opening to the right, that is in the positive direction, and so my equation is positive. I should be positive over here on the right side, that 1 over 8. So that's our equation. Let's look at the next example. This time we're graphing an ellipse that has a center at -2,3, a vertex of -7,3, and a focus of 5,3. So I'm going to start with that center, -2,3. We'll put that right here. And then I have a vertex out here at -7 and a focus at -5. Okay, so we have a horizontal parabola here. If we want to get the other vertex at the end of the major axis, that's going to be 5 units away from -2, since this vertex is at -7. My other one would be over here at 3. And in order to complete the graph of the ellipse, we need to know how long the minor axis is. And so to figure this out, in an ellipse, we have this relationship, a squared is equal to b squared plus c squared. The a squared, that's going to be the distance from the center to a vertex on the major axis. This is going to be a. The c squared, that's the distance here to the focus, that's c. And then b, that's the distance that we don't have right now, but that's going to be the distance from the center to the vertex of the minor axis. So we can solve for that value because we do have a and c. My a is 5, so I've got 5 squared equals b squared plus, and my c value, distance from the center to a focus, is 3. And so 25 equals b squared plus 9, b squared is 16, and b is 4. Sorry about that, that's my coffee pot telling me the coffee's ready. And so if that b value is 4, that means that our ellipse is going to go up as high as 7 and as low as -1, maybe right here. And so there's the graph of our ellipse. So now we need an equation. Our equation is going to be in the form of x minus h squared over a squared, and the a goes with the x because our ellipse is going horizontally, plus y minus k squared over b squared is equal to 1. That's our formula for this equation. And so my center is at negative 2, 3, so I have x plus 2 squared and y minus 3 squared. And my a value is 5, so this is going to be over 25. My b value is 4, so this is going to be over 16. And that's our equation for this ellipse. Last example is a hyperbola. So we're going to start with the graph. We have a center at 3, negative 2. Center of our hyperbola. We have a vertex at 3, negative 7. And then a focus at 3, negative 9. So based on that information, I can see that this hyperbola is going to open up and down. But in order to complete this graph, again, we need that b value. We have the a value, which is from the center to a vertex. This distance is going to be a. We have the c value, which again is the distance from the center to the focus, c. But we need the b value to complete our equation for the hyperbola. With hyperbolas, the relationship is c squared is equal to a squared plus b squared, because in this case the c is going to be the longest value, as opposed to with the ellipse where the a was the longer value. So my c value here is 7. So 7 squared is equal to, my a value is 5. 5 squared plus b squared. So 49 equals 25 plus b squared. And b squared is 24. B is the square root of 24, which could be simplified. We're just going to leave it in that form because we're going to square it anyway when we write our equation. So to finish sketching this, this graph, if b is the square root of 24, that's pretty close to 5. And so from 3, that means we're going to go out to almost 8. I'm going to mark 8 here, and we'll just go just short of that. And then we're going to go out to almost negative 2. Just short of that. Now remember with the ellipse, this is a hyperbola. With the hyperbola, we sketch this box. Oh, sorry, from the center we need to go up 5. So let's see, we're at 2. That's going to put us up here at 3. Okay, we sketch that box. I am really not symmetrical here at all, but we're going to go with it. And we have our asymptotes that go through the corners of the box, and then our hyperbola we determine opens up and down because of the placement of that focus. We know that it's a vertical hyperbola. And there's our graph. Sorry, it's not a very attractive graph, but it is the graph nonetheless. And the last thing we need to do is write this equation. Now, since it's opening up and down, that means that my y part of the equation, that's the part that's going to be squared. So my equation is going to be in the form y minus k squared over a squared minus, remember hyperbola is the one that has the minus, x minus h squared over b squared equals 1. And my center is at 3, negative 2, so that means we're going to have y plus 2 squared minus x minus 3 squared. And my a value was 5, so this is going to be over 25. And the b value was the square root of 24, And if I square the square root of 24, then we get 24. And so there's our equation for this hyperbola.